Among different diseases, different types of cancer are very crucial because they're complex system. To understand what happens in different cancer, we have to know what the elements are: genes, microRNAs, proteins, drugs, lifestyles, or environmental effects. Drugs, as one of most important part of the cancer system, can be considered as the very important role. They have important role in the cancer. You know, one drug from an initial idea to one product in a market, it takes around 17 to 20 years and at least $2 or $3 billion of the investment. In those countries with that they have a limitation in the financial resources, we have to find alternative methods to design or discover drugs for the cancers. Drug repositioning, which is a shortcut for drug design, is considered as a very informative method in cancer studies. In drug repositioning, we can use existing drugs for new inclination, especially cancers. In drug repositioning, we can use computational approaches like machine learning or other methods to identify the potential interaction among drugs and targets, with targets can considered as proteins, genes, or microRNAs. Our case study in this study is breast cancer because of its importance in the world. You know that in the US and Canada, breast cancer, especially among women, it is considered as a very common disease, and that's why we opt for the breast cancer. Up until now, our results, we are studying this study in 3 levels: for microRNAs, interaction between drugs and microRNAs, interaction between drugs and transcription factors, and interaction between drugs and genes. We are in our first step for interaction between microRNAs and drugs. In this step, our results, we have found among 2,000 FDA-approved drugs, we have nominated around 69 drugs to be used in breast cancer network, and computationally validation has been done, and now we are working on the experimental validation to candidate new drugs in breast cancer. That's it.